Okay, thank you.
Yeah.
Thank you very much for coming. I just recently discovered animations for PowerPoint, so I maybe have overdone it a little bit, and I may start saying something before it shows up, so you have to forgive me on that. So let's begin. This is, I've got a few test databases, test collections on a MongoDB cluster I set up. I'll talk about what that is a little later. And this is a data collection called Families with Players. It's part of a youth sports database I run for one of my clients. And I've copied some of the data out and randomized the names, so there are names of kids in there, but they're not real. And that is what you see in a collection. That's not all of it. There's players array begins here, and it goes off the bottom of this screen. So each family in this data, there's about 20,000 families and about 55,000 players in this collection. And this is what we're going to have instead of SQL tables, SQL-like tables. And so when I first discovered this, I sort of said, why? Doesn't ESS almost work? Wouldn't SQL be an easier transition to make? We're used to looking at things that look like this. And now we have to look at things that look like that. So,
Nice animation, by the way.
Sorry?
Nice animation.
Thank you very much. So we'd all been wondering what is going to come after, at least I had, I assume some other people had too, what is coming after FMP12, .fmp12. We were looking for scalability, wide area network performance, also on the presentation side looking for responsive layouts and so on and so on. So about this time last year, a month or so earlier, we heard it was going to be MongoDB, and I've sort of been digging into that a little bit since then. I'm not a MongoDB coder, I'm not a deep expert in it, but I have been through getting a few demonstrations to work. And I've just recovered from FP7, so so I'm just, there's a certain amount of trepidation around here. Sorry, yeah, that's working. What am I not seeing? Presenter view. Sorry. So this is, I haven't begun the presentation yet. There is an Australian comic called Hannah Gadsby. I don't know if anybody has seen her stuff, but she starts her stand-up comedy. She's on Netflix. And she starts by saying, I haven't begun the show yet. I want to manage your expectations first by setting them. So she goes through a list of what is going to happen in order, when the jokes are going to be, what they're going to be about, and so on. And she finishes with a joke punchline, the last few seconds. The punchline to a joke she actually set up 45 minutes earlier, and you don't notice that that's what it's going to be. So, oh yeah, she said. So all the way through, the entertainment is so funny and absorbing that you forget what you said. So that is the standard of entertainment I'm aspiring to, probably unsuccessfully. But if you have worshipped at the altar of fourth normal form and been a good person all your life with FileMaker, you're going to have to make some adjustments in thinking and drop some paradigms. In fact, to borrow a phrase from Apple, you're going to need to think different. So what I want to do is not so much get into the details of coding MongoDB, which is good because I don't know how to do it really, but try and scope out the kind of performance benefits and the potential that MongoDB has, and then tell you what my contacts at Cupertino have told me about what Claris is going to do with that and deliver for us. Unfortunately, my contacts in Cupertino don't actually work for Claris, so it's pure speculation at this point. So the first thing we're going to do is we're going to talk about the basics, just a quick outline of the key things you need to know about MongoDB and how it compares with a table-driven data structure. Then we're going to talk about how we organize data in MongoDB, and that's basically data modeling, data structures, the alternatives you might have. Then we're going to talk about whether we can access MongoDB data from Claris Pro, and the answer is yes, you can. Sorry, go back. You can obviously see Claris Studio data, which is MongoDB at the back end, but you can also use an ODBC driver that MongoDB supply to look at a tabulated version of MongoDB collections. That's a read-only tool, and it was designed, it's not really designed to work with the data in any big way. It was designed to supply high volumes of data in table form for business analytics to use in things like Tableau, or actually you can use it in Excel as well. But it does take a quick peek at it from a FileMaker app, which is sort of fun. Then we're going to look at performance. How does a basic database administration task function with a MongoDB backend, with a MySQL backend using ESS, and via Draco? I was going to try and do the same thing using the tables stored in same table structure stored in Claris Studio tables, but I decided not to do that for reasons I'll explain at the time. I'm trying to run scripts that will run on each platform's backend, on sort of server-side scripting. And the only way you can do that with Claris Studio is to run FileMaker scripting bolted on to those Claris Studio tables. And it doesn't work very well at this point. I hope sometime we'll be able to do that. So let's go to the basic. Oh, and then I'm going to look at resources, some educational learning resources, and some client-side tools you can use to actually look at MongoDB data aside from Claris Pro. Any questions so far? Okay. I warn you, there are going to be a couple of jokes. I'm going to attempt. And I better, sometimes comics do this now. They say there might be some jokes that you find offensive, so I'm going to tell you now. They are actually at the expense of Draco. So if you feel you need to block your ears or leave the room, I won't be upset. But they're the kind of loving ribbing based on decades of a loving relationship. The kind of jokes you would tell at someone's funeral, actually. MongoDB saves data as JSON documents. And here's an example. It's about a movie. It tells you what genres. There's an array saying what genres it belongs to. And there's another array saying who the cast is, and a text value pair saying that what the name of the movie is. And a collection is a group of documents. So where we would have a table and rows, we have a collection and documents. All the fields, all the content for a quote row is in one document. Not only that, but the names of each field, like a JSON object, are named within the document. So the schema is defined by what you write into each document. And for many applications, for one collection, the structure of each document will be identical through the whole thing. But that's not a requirement at all. You can mix different kinds of objects in the same collection. And what's more, you can add a new field, obviously, by just including an adjacent object. The schema is defined as you go. Which obviously is very different from FileMaker, different from a SQL database, which has a fixed schema that you have to manage. And every time you want something new, you have to go into the design backend and add the column, the row, whatever it is, and then you can start putting data in it. A typical SQL-like, and I include FileMaker in this because you're dealing with tables and normalized relationships, has data tables, rows with columns. Typically you have join tables if you have many relationships. So if you have obviously a database which includes students, in other words, another table that includes classes that they attend. You have a join table that says which students in which class. Little pair class value pairs between class ID and student ID. And by looking at that table, you can say what is the class enrollment list for a given student, or for a class, what is the who's enrolled in this class. And I think most of us know that. So, and you can. Let me go to the next one. I put no join tables there, but there's an asterisk by it, which I'll come back to. We have collections, we have documents. We don't have join tables, usually. On-the-fly schema evolution. You can create a join collection, and you can emulate a normalized database and the way many relationships are handled with that. In fact, as I understand, most people who actually develop MongoDB solutions don't do that. In fact, one of them I spoke to says, if that's what you're going to have to do, you're better off with SQL or Oracle. When you create a MongoDB cluster using Atlas, which is their online service for managing MongoDB installations, it automatically creates at least 2 more copies of the data called nodes. And the 3 nodes are referred to as a replica set with a primary node and 2 secondary nodes. And a MongoDB app usually reads and writes to the primary node, which are continuously backed up to the secondary node. If for some reason the primary node goes down or stops functioning, automatically a secondary node is promoted to be the primary node, and it replicates itself. So it's like a starfish that has a leg cut off. It just fixes itself. You can have a lot more nodes, and there are a whole lot of structures they make available to provide replicated live data around the world. And not that I don't know enough about that to talk about much more about that, though. Documents are presented. They present as JSON strings, but they're actually stored in a format called, I think it's pronounced boson or bson. If somebody knows, they can tell me. And they're highly indexable and highly structured. So whereas the JSON, so the JSON you see is kind of like Plato's shadow on the wall of a cave. It's not the real thing. It's a sort of mapping or a isomorphic image of it. But the real thing is deeper inside. And MongoDB knows exactly where to find each piece of a document. Draco doesn't know how to find each piece of a document. You have to load the whole thing, basically, and then find it. I think on the client side, mostly. They're stored as binary objects, and you can specify whatever indexes you want, and the indexes are stored in separate files. And more importantly, if you run a query that's based only on index fields, it only needs the index to get you the answer back. It doesn't need to actually go into the main data store at all. And so queries based on indexes are really fast. So a multi-node structure can be just stored in a single document, as I said, and the data or the sub-element of it can be retrieved very quickly. If you have a layout in FileMaker and you have a couple of portals on it, that sort of defines a hierarchical view into your data. So there's something of an analog between a layout, or rather the abstracted version layout without the visual piece. And in fact, if you use the data API, it basically, you go to a layout and then you are looking at something a bit like a JSON object or a MongoDB document. Here's a simple example, a simpler, easy to read example. We have a collection of people, and with each person is an address. This was written some time ago, because George Bush was only 45. And you can, I mean, if somebody had an address with 2 street lines, like a street and an apartment number, or a street and well, a lot of English addresses have more than 1 street. You can just put them in and they're available. But the first question a FileMaker developer is going to ask, I think, is suppose that address is for a business location shared by many people, and the address changes for all of them at the same time. Mongo documents can use things called DB references to define a relationship between two collections. So here is a person object. It's in alphabetical order. No, it isn't. Yes, it is, I think. Yeah, because dollar. Yeah, it is. But you'll see the name is at the bottom there for Tom Benjamin. And you'll see that the address is a sub-object, and it has three elements to it: a ref, which is the name of the object, an ID, which is an object ID, and a database that that object comes from. Notice it doesn't say what collection it's in that database. It's got a universally unique ID for that object ID. So that's the only time, so MongoDB can figure out where in the whole database it is without knowing which collection to look in. And that links to an address object where you can find out exactly which address applies to this person and to anybody else who has the same reference ID in their record. One thing that is important is that if you're running a query on a collection that uses DB references, it doesn't load the reference data automatically. There has to be a separate process to get that to run through it. That's about all I'm going to say about DB references. I don't know quite enough to explain, but when I talked to Mongo about it, they pointed out that they really used for very sophisticated applications, or even crossing complete databases, not just collections, or data in different clusters and so on. And they're very powerful for certain things. But I'm not going to go any further with that today. I'm going to look at organizing data in MongoDB, sort of lead in to that. And we're going to look at alternative data structures that might be employed, and there are a lot of choices. Aggregation pipelines, which are queries basically, and views, which are virtual collections based on the result of an aggregation pipeline. And then we look at triggers. Triggers is a server-side trigger, such as used in SQL databases, that's not available in Draco, but says if this changes, run this script and change a bunch of other stuff. And they're very much part of the MongoDB design approach. And we're going to take a youth sports database case with two of the tables that are actually from one of my clients' systems, families and players. Because it's a youth database, no contact information is stored with the player record. They're always contacted through their parent contact information, which is in the families table. So if you want to address some communications to the player, it has to look up the email address for the family, or the phone number, or whatever. Each player belongs to one family, no surprise there. And we have an operational need to manage players and families as distinct lists. You deal with players to enroll them one by one in programs. You deal with families to have them pay for things, to do marketing emails through MailChimp, and sort of general operations that aren't, they might be player specific if there's only one player in the family, but they would, it's a different operational process to deal with the families grouping and the players grouping. Now with Draco or with SQL, it's easy. You've got two tables, you use one or the other, and you can look up the contact information if you need it. But we're going to look at, that's obviously the typical relationship graph in FileMaker you'd see for that. And we're going to look at typical MongoDB approaches. One is a families object with an array of players based in it. Simple. So all the data in that place, and the other time you need some information, dig into that and get it out. Another is to use a families table plus a players table with the family information embedded in it. So you have a families table to deal with families as a grouping, and you have a players table with the family information you need for each player in the same table as well. So now I'm duplicating data. And the other way is to just use the typical normalized approach of separate families and players table. And there are more approaches to use. There's an article, 6 Rules of Thumb, on choosing data formats, which there's a link to at the end. There is a PDF I uploaded with all the links to the learning materials and some articles and where to download some client-side tools, which will be useful. So families with player embedded is, I think, the most likely place a coder for MongoDB would start with this. And there's a players array in the middle, and that actually points to an array of actual individual players with name, age, date of birth, player rating, and a few other things. This is a bit simplified from the actual application that uses this data, but it's, I think that's pretty clear. It's very efficient for dealing with the family as a unit. When you want to bring up their logon page on the website, their information is there, their players' information is there, they can edit, update any of it. It's less convenient if you want to collate or group players based on attributes of the player alone. So find me players whose player rating is above level 5 who will be eligible for such and such an event. Find players whose zip code is such and such, or who live in this state or that state, to do some promotion for just those families. Find those players, then find the families, and so on. So a families table, we know what the families table is like. This is what a player with embedded family data would be like. So I have the same kind of player information with an embedded sub-object, which is the family for that player. Less storage efficient. Obviously, we're duplicating data. Storage efficiency isn't as important as it was back in CJ Date's day. Denormalized structure requires a trigger to maintain data integrity, though, so that when I change a family's address, all the players get updated. But the player is the root object, which makes it easier to use the collection as a players table. If I use separate families and players tables like we would in FileMaker, it's more complex for retrieving and updating a family as a unit. But the normalized approach is very familiar to Claris developers. Views. From families with players collection, we can build a virtual players connection, or a view, whose documents would look like this. Player information with some data that comes from the family record. And views are created using aggregation pipelines, which are really cool. And they're not that hard to get running once you've worked with them a little bit. A pipeline is a series of queries or stages applied cumulatively to a source collection. And a SQL parallel of some sort might be a view based on a view based on a view, or using a SQL sub-selection inside a SQL query. And a pipeline can be saved as a MongoDB view or executed with the result saved to another collection. What's important about that is if you do that, create the separate collection and apply indexes to that collection to make it easy to search, even when it's repopulated from scratch, those indexes remain. So we're using four stages in our pipeline. Rather than show you the interface from the MongoDB admin panel, I'm going to just make it more diagrammatic and easily to understand. We start with a family that's got, say, in this case, 2 players. So there's some family fields, and there's, in this case, 2 players, and within each player, there's some player fields. And then we go through a step called project, which removes or suppresses fields from the family level that we don't need for this particular. Maybe we only really need the zip code, email, and phone number for a player, or the state, zip code, email, whatever. We don't need everything about what the MailChimp subscription status of the family is for that player at that time. And that's called a project stage. It's a bit like Facebook. It doesn't show you stuff you don't actually need to see. That's a lame joke, just in case you didn't get it. Then we do something called unwind, which creates a separate object for each player. So basically, for each element of the player array, I now get 2 documents with the same family data, but the different player data. So it's something like a full left join in SQL. And then we do something called replace with, which is write an expression that replaces the entire object. In this case, it keeps the root family level and uses something called merge objects to take the player up, which is a calculation, takes the elements of the now single sub-object, which is the player, which is not an array anymore, it's a sub-object, and promotes them to the root level. And then we do another project which actually drops out the player sub-object itself. So we're left with a flat table. Now, what is important to understand, it looks like we're moving stuff around here. We're not moving anything around. We're just changing the rules through which a query or a request for data will read through the elements in that JSON object. It hasn't changed, we haven't changed it. It's just a different way of reading stuff. And again, Mongo knows exactly where to find everything. It just, instead of dumping it out looking like a JSON object, it like jumps out the way we'd like to see it, which is like that. I mean, it doesn't look like that in Mongo, but if you load it into FileMaker or Claris Pro, that's what you'll see, with the player data and the family data attached to it. Sorry, yeah, that way. So I don't quite know, we're going back there. Oh yes, well, we're going to talk about this. Where were we? Yes, sorry, in JSON it looks like this, basically. It's an array, each array element, that loops around it, it's on, it's all one thing. Each array element is one of the stages. It includes its definition, and so on and so on. So that's basically, and you can use that pipeline with an API call, have it run, and you can also do something, adding what's called an out stage with a name for a collection that it will create on the fly, and it will save the result of that query as a table, not just as a view. You can also make it define a view to just run that query to define data. And that's fine up to a point. If you want to look at all 20,000 or 59,000 players, trying to sort through a view and do searches on the view or so on the view is not very fast. So we have this option, and it also can be indexed. So I was going to say something, yes. Running that pipeline and creating that table with the result. It will not only load the outcome into the table, it'll truncate that collection first and then just update it completely. It takes 4 seconds to run.
Is that good or bad?
That's pretty good. 55,000 people, 20,000 families go through that. It's all done server side, it's right there. I think it's pretty good. Well, we'll take some bets on how long it would take Draco to do it, but this is basically, we can use this, and this gives us this players with family embedded table. We're going to go back to this. And a trigger can be set up to automatically update related tables when a family document is updated. And we're going to run a movie here. Here I've actually used the ODBC driver to look at players with family embedded and the related family document in the families collection. And the purple fields are ones that are data that's shared in both collections. And I'm going to just show you, sorry, no, I'm not. I think I have to click on it to make it run. Hang on. It is a movie? No, it's actually a movie, so it should, well, oh, why isn't it running? Sorry, I thought it was, I can actually show you the movie later. I wanted to do it though, because it's kind of cool. Sorry? Yeah, okay, I'll do that, okay. I thought I had this pasted in as a movie, so let me just, this one, where I want to go. I'll tell you what, oh, darn it. Is that a movie or is that not a movie? Yeah, there it is, okay. Play it, okay, and we'll go back to play from current slide. Yeah, sorry, yeah, I have to just roll over the right piece, I'm sorry. Okay, so I'm actually going to use Navicat for MongoDB. And I'm going to go into the family record there, and I'm going to format that phone number properly. And just change the zip code. And save that, and then switch back, and click refresh. And it's updated both at the same time. Pretty simple, nothing particularly dramatic about that. But it is these pipelines, not quite the words, these links between various data structures that can continually keep the data integrity intact across, lets you build data structures that are going to load very fast and work well for an application, and everything to keep it all in shape at the back end is can be made automatic. It takes a bit of coding to do that, but that is so different from the idea of a normalized data structure. But, you know, when the theory of normalized fourth normal form came out, 1960 something, I don't know when it was written, we didn't have solid state drives. We didn't have massively powerful processing. So the idea of trying to do that at the same time as running a database would have been not in the universe of people's imagination, I think, then. But in fact, when you have a structure with just the tables, even in SQL, you'll use denormalization and triggers to get things to work faster. And then in FileMaker, particularly with Draco, I do a lot of server-side scripts to make things work at a reasonable speed. And then you find you're really just doing what MongoDB does, but it's done in a way that's meant to be working that way in the first place. So it is a different way of looking at the world, and it will take, I think, some getting used to. We're going to do just a quick look at accessing MongoDB data from Claris Pro. We're going to look at Claris Studio tables, MongoDB via ESS, and the MongoDB API. So here's an overview. This is a movie, if I can get it to work. Yes, here it is. I've got 4 tabs, and they show the same essential data, not quite in the same order, but if I run this, you'll see, that is in FileMaker, Claris Studio, MySQL using ESS, and MongoDB using ESS. The ODBC driver, I mentioned it's read-only. I made it work on Windows. I made it work on an Intel Mac, but not an M1 chip, because the internal executable file is not compiled for ARM processors. And I mainly work on FileMaker Server for Windows, but not for Claris Pro Server. I don't know. I've installed it properly on Linux and so on. I have a case running with support. Apart from the fact there's no guarantee that anything other than one of the list of databases will be supported, they are, I think, trying to figure out why it's not working. So it does work on FileMaker Server. So actually, to get this to work, I cheated. I put a local file using a local driver on this. This is an Amazon instance running in Virginia. And I put a local file that uses the ODBC driver installed on Windows to get the data, and it's an external file to this demo file, so it sort of looks like it's getting it from the source. This is the MongoDB data API. I've got they have an API, and you have these HTTPS endpoints. There's a bunch of standard ones. To do things actually write or change the data structure, you have to have what's called a custom endpoint that you have to write a function for. You can actually write one function for everything you need and use parameters in your submitted JSON packet, curl post to branch based on that. I've got two that I set up, one of which I think this is a movie. I'm going to first delete all the data in the. I have a table of potential duplicate players, and I have a function that will delete all those and then repopulate it with a new run thing again. So that is, I click submit. It takes 0.2 seconds to truncate the table. It's got about 130 records in it, and I'm going to submit to actually run the query again over 59,000 players and 20,000 families to see if there are any duplicates. And I'll explain the task a bit next step. Exploring performance. I'm going to look at MongoDB, MySQL, and Draco doing that task. Server-side script, running the first, in the case of Draco, the fastest way I could get it to run. So a two-table collection model we had before. These are run without any denormalization, so we're looking at the same thing. Now, in FileMaker, to do something like this, you'd probably run a server-side script to run through and denormalize and make it easy to do this. You might do the same in SQL as well. And you might have a different structure altogether in MongoDB in the first place. But this is just to 56,000 players, 21,000 families. To find players that may exist more than once in the data, it's because families, one spouse signs up a kid with one email, then dad has to sign the same player up, has lost the thing, just creates a new account with a different email, and now you've got the same player in the database twice, two separate family records. So you need to, and it happens all the time with public subscription databases. It's a plague of the industry, basically. So you have to find a list of all the potential duplicates, and that will point to the records that you need to figure out how you're going to merge, merge all their enrollments and things that they purchased. It's fairly complicated, which I'm not going to show here, obviously. But we're going to look at whether a last name, gender, date of birth, and zip code is the same for two players. Then they're probably a duplicate. It could be twin girls or twin boys, but and the zip code is in a table you have to look things up from. So we're going to perform this task, and we're going to go and do it with MongoDB first, I think. Yes. I got to run a movie here, sorry. Give me a sec. Yeah, here we go. So we're going to do MongoDB, and we're going to do that. Oh, sorry, that was, deleted the 1.6 seconds. We're going to refresh it using an API call. And it takes 6.9 seconds. 59,000 records, 20,000 families, looks it up, finds deep. So it's found each unique last name, gender, date of birth, zip code, and account for how many players have that same specification. And now we're going to do it with MySQL. 1.1 seconds, which is actually quite amazing to me. It blew my mind when I saw that. Just going back to the MongoDB situation, if you delete all the documents in a collection and pending repopulating that collection, you query that data using the ODBC driver, it will come back and say database missing, table missing. Because when you delete the content, you delete the schema. And I got away with it because I didn't try and reload that table until it had been set up again. But once that's happened, the only way is actually to create the external data source all over again. In case you get into that, you want to find out a bit. Now I want to take some bets. How long do you think it'll take Draco to do this running with a server-side script? And the way it works is it matches up players who have a different player ID but the same gender, date of birth, and last name, and filters down to those. And then it goes through checking whether the zip codes and the families match within that. There's a constrained found set to find them. And then exports it to a text file with a group by to get down to 1 record per player, and then imports that. That last step takes no time at all, effectively. So does anybody want to place a bet?
2 minutes?
2 minutes. Anyone go a little lower than that?
50 seconds.
50 seconds?
Getting a coffee?
5
Yes.
seconds.
Okay. It's what I call a Starbucks query, which means I want to be positive about Draco. Of course, this is the lame joke. But if you go out for a coffee, there's a positive, but better than 50% chance it'll finish running when you get back. So
there's 25 seconds then.
So we're going to go to.
Espresso fix.
Well, it depends how far away the Starbucks is, obviously. So we're going to go to Draco this time. Whoops, sorry. And I'm going to go down. Sorry, I got ahead of myself there. I'm not used to this. Is complicated to me. There we go. We're going to watch the movie. I was afraid I wouldn't fill up the whole hour, so.
So how are you doing this again?
Okay, it's running server side.
Yeah.
But it says, okay, I've got a self-relationship between the players based on gender, date of birth, and last name. So it finds all the matches on those, and it has to use a calculated field to see whether it matches the family zip codes match between those two players. So it does a constrained found set on that, then sorts it, and then groups it. It's the original search plus the search on the related field that takes the time. I tried doing it with execute SQL, but using execute SQL with a group by an account on a large data set if you didn't have a having greater than 2, count greater than 1, at the end it might have worked, but once you put the having clause on the end of a large data set. So 52 seconds, so that wasn't bad. I didn't discuss this with you in advance, did I? I can't remember. It's not bad for Draco, but clearly we got some potential for some massive improvements here. So I'm surprised that that SQL was so much faster, to be honest. Yeah.
Just an additional question.
Please.
I'm not blowing things up. Is that MongoDB advantage against Draco still leveraged if I'm using normalized tables in MongoDB, or am I losing something?
I am using normalized tables in MongoDB, actually. It does a lookup from the families table. I'm using the two-table model actually in MongoDB.
Okay.
So there's a stage called a lookup, which is kind of like a lookup in FileMaker actually. It says get this, and then there's a group by, and you add a count field to the group by step, and then you say match that group by that count being greater than 1. And I actually ran it on Atlas on the back end, and it takes most of those 5 seconds. So the latency to go and send the query out and get the query back and load the data through the driver is maximum 1 second of that.
Now, I was just wondering if there was a performance difference in the
Oh, I'm
three
sorry.
models that
Yes.
you were.
Sorry, I've only tried it because I want to make it apples and apples pretty much, the two table.
Yeah.
I haven't tried it, but I'll be happy to try it later and let you know. I would think it would be pretty fast if I did it straight in the single table, which you have to build obviously. So it's 4 seconds to make sure that's up to date. Although with the triggers, it stays up to date all the time. I could try it. I'd have to build a pipeline for that, so I can do it. But Draco, as you may know, was developed when J.K. Rowling was a FileMaker developer, before she wrote her first Harry Potter novel. I'll just let that sit there. That's a bad joke.
Is it difficult really to compare apples with apples, because you wouldn't structure, if you knew that was a search you were going to do regularly, you wouldn't build it like that in FileMaker, but then I suppose MongoDB, you wouldn't make that a two-table model by default anyway.
Right,
So
you would do it that way in SQL, and that's what it's designed to do.
In sort of comparing not apples with apples, but with like the most optimized way you do it probably in
Yes.
and just
But
Mongo still has the pants off.
a great deal of that is end running the weaknesses of Draco, and I didn't. Yeah, you could do that, but it's one thing to do normalization to make something reasonably fast even faster, but to overcome things that the database should do anyway. I'm not, well, anyway, I love Draco. Anyway, I mean, given how much money I made over 20 years from that platform, I shouldn't be slagging it. But, you know, I think everybody knows it has its limits. Again, Claris Studio, it's not so much getting a coffee. If I tried to run this on a Claris Studio table, it'd be, if I started running in New York, would it be finished by the time I got to Copenhagen. I tried to run it on just 2,000 players, not even trying to do the database match, the zip code match, just running on one table. But it's using FileMaker script to find the right records to match. And then it's exporting that to a data file and re-importing into. I used a FileMaker table on the final front end to make it a little faster than trying to import it into Claris Studio. And you can't control the indexing of the Claris Studio. You have no way to improve the performance on the back end yet. But I hope, I'm trying to give an idea of what Mongo can do. I'm going to quickly talk about resources. Client-side tools, there's a thing called Compass, which I will just open, which is given to you free by MongoDB. And it lets me look at my data. I hope it does. Yeah, I'm running a VPN to the States here, so it runs reasonably fast. And it lets you fill your data. That's my database. Families with players is here. I can open it up, and I can look at a tree view or a JSON view. I think I've got an aggregation stored with that. Pipeline. I don't have a pipeline saved with that, but you can manage all your queries. You can run them and test them, and it's pretty good actually. The next one is something called Studio 3T. Have I got it here? Yes, it is. Here it is. Sorry?
The little logo is a manatee.
Oh, is it really?
Green manatee.
Oh, I didn't. I thought it was something like that. So I go to my database. I can see my data. I can look at my families table.
Oh, nice.
And sort of, I can't remember what the favorite tool for managing Oracle database is. It looks kind of like that. There's something really clever though. There's a thing called a visual query builder, and it lets you build pipeline stages and so on, and somewhere SQL. Select star from families. You can write in a SQL query, and it converts it to what? Oh, do I? Yeah. Okay. Yeah. Sorry. Select file for the query code. It gives you the MongoDB shellcode to do that, which is really useful. It may not give you the most efficient query, but it's a starting point to fine-tune something and create a pipeline for something that works. This is the only tool I've come across that does this. There's also...
Just explain it.
Oh, sorry, beg your pardon. Where was I? Yeah. There's a very good explain. The Atlas web portal gives you very good explain. It tells you pretty much exactly what's costing you. I haven't quite mastered its syntax completely, but so we're going to go here, weren't we? And we were going to run families, and we're going to look at where were we going to go? SQL. Select star from families. Run it, and yeah, it gives you an explain, which is going to be pretty simple actually. Oh, without click the light bulb in the corner, which is here, which gives you a bit more information. So so if you're used to explains in SQL, yeah, that's really handy actually. So the other tool that I kind of like is Navicat for MongoDB. So, oh, shoot, I'm going to just keep with the trial. And I use it because I use Navicat for SQL a lot. So I'm sort of used to the way it begins to look at things. If I go into here and look at, say, collections, families with players, and look at a tabular view, actually I'm going to use players with family actually, because it's a single object, not an array. When I scroll across, where are we? Family document 21 fields. I think I can open that up. Have I got it right? Maybe I have to. Oh, sorry, I have to do it here. Notice that the implicit column name for a flattened document is the JSON path to that value, which is really useful if you're dealing with a table in FileMaker that you need to build a JSON object and you have the column name equaling the path. It makes it really easy to calculate. So if this were a QuickBooks ledger entry or something, it would come in really handy to assemble a JSON packet to go and post that in the QuickBooks API. So those are client-side tools. The next one is, if I can get this thing to work right. Okay, a list of learning resources. There's a little book of 80 pages called the Little MongoDB book, which is where I started. It's 80 pages. You can read it in a couple of hours, faster probably if you have some idea before you start. And I recommend it. It's like $8 or something, and it's on Apple or Kindle. it gives you a good starting point, a sort of macroscopic view of things. There are two sites provided by MongoDB itself, the MongoDB Basics Guide and MongoDB University. And MongoDB University is a full-length course, and it has different introductory sections for JavaScript developers and another one for SQL pros oriented to where they'd be coming from. They don't have one for FileMaker people yet. There's an article on one of their blogs called 6 Rules of Thumb for MongoDB Schema Design. Another blog post on views versus denormalization. That mapping chart there's nothing particularly I haven't covered already in that, but it's there. The BSON says that's a Wikipedia article explaining how BSON works on the inside, if you're into that kind of thing. And now we have the one more punchline piece. It's a case study for a client who runs a small business, and he inspects and certifies medical equipment in medical and dental facilities and some veterinary facilities, mostly in Connecticut and Massachusetts, northeast United States. And there are 55,000 pieces of equipment, each of which is located in one of 2,000 facilities. Each equipment item has 2 to 10 measurements that need to be done annually, depending on the type of the equipment. There are 700 types, and each has its own list of required measurements and its own pass criteria, what those measurements have to exceed for that type of equipment. So, same measurements for different equipment, but different rules for whether they pass or not. Each facility might have up to 300 equipment items. A lot of them have just 10 or 15 or 20, but a doctor's office or a medical office in a school or something like that. But a retirement home or a rehab center could have at least 300 or more, actually. And so usually annually, a visit is set up where a technician goes there and tests all the equipment, enters the data. It's all done on an iPad in the field. Then you have to say, has it passed? Each measurement, you have to say that's okay. An inspection is a set of measurement results for one piece of equipment. And it has passed the inspection is okay if all the measurements are okay. And a measurement's complete if it's done and passed. An inspection's complete if all its measurements are complete. And a visit is complete if all its inspections are complete. So this is basically a nightmare.
What do you have for get certified?
And the client wants to know things like, are there any visits whose due date is passed but are not complete? So if you didn't do some denormalization, and they could never answer that question, basically, without... and the way we do it is actually, when a test is passed, it's marked as passed. When all the tests are passed, they actually write into the data that the inspection is complete. Then each inspection is looked at, and with a server-side script, when they get to look and say, it looks like this one's okay, do you want to mark it as permanently complete? So then when you say, are there any that are not complete, it only shows you the ones that are not so marked. So it works reasonably fast. Even so, that client has insisted on using remote desktop to get some speed because of the latency. It's the problem. So if you think about what happened, so if I were developing a table-driven application, I don't bother to read them all, but there's a complex table structure with everything that's there.
How can you get 2 routes to the same table?
By putting 2 TOs on top of each other. This wasn't meant to be FileMaker specific.
That was a trick question.
I just thought this would in a SQL app you wouldn't worry about the loops. You might worry about them, but you can have them. So if we go through the calculations that are required, we first have to say, is the measurement passed? And that's a calculation based on the measurement results and the criteria for that test. So it has to reference the equipment table, the equipment types table, the test profiles table, and the measurements types table to know that. unless you, when you set up the visit, you write that data into the measurement record initially, which is what we do actually. Is an inspection complete? That's a calculation based on its measurements. Is a visit complete? Is a calculation based on its inspections. And then you have to search for completeness versus the date to find out which visits need to have attention paid to them. What if we could pull all this information into a single document? It's a bit more complicated than this because there's information about the equipment you're going to need on the spot. So you probably need the equipment table or an equipment level in here, and then the inspections for each equipment, and so on and so on. But if you had a document that you could load before the visit in basically one record, everything I need in the field is available loading one record, as opposed to winding through different tables to bring it up and searching for things. Have you ever tried duplicating a record that has a set of related records? You have to go through and loop through the related records, copy all those and make sure it doesn't screw up. And let alone if it has related records within each, you've got 2 levels down. With MongoDB, kaboom, done. Duplicate one document. So I could use a view that shows me this and have my client-side application actually write the results right back into a separate measurement collection. So I could keep all those separate things if I want. But when I look at what you do to denormalize, I'm sort of doing what MongoDB does, basically. I could create this view, or I could create a permanent record. I could use triggers to update it all the time. You can't have a stored calculation in MongoDB for a result, for instance, comparing the actual measurement with the criteria for a measurement yet. But they're going to have in their development pipeline is the ability to write an index based on a calculation. So line item, quantity times volume, quantity times price gives you whatever the word is, big price, I can't remember the word. Total price, or extended price actually is what it is. And if you wanted to search invoice line items for everything over $1,000, for example, for a business, SQL, that's easy. You just do a virtual stored field. It does it for you. But MongoDB will be able to actually, because the schema is so fluid, it's not clear how you can actually create a field in a document that did that. But you can say, create an index for that, so I can search on that calculation. Yeah.
You need to kind of wrap up now with questions, so people are trying to get some coffee before next.
Okay, I'm glad I managed to fill the hour. I was worried about that. Okay. Any questions? Okay.